Today we're going to talk about Sn1 reaction, which stands for substitution, nucleophile, and intermolecular. So we see in our mechanism that both molecules are stable, so there is no reaction. So to be able to have a reaction, we need to add heat, which makes these electrons, and electrons in the whole molecule, speed up, they go faster, so they start to look for a more stable atom, which in this case is a bromine because it has a bigger shell and it's more electronegative, so it's able to hold and stabilize electrons. So better than carbon in this case. So our electrons on the sigma bond, they move towards our carbon, our bromine, sorry, and it forms our carbocation. And then bromine leaves and it becomes negative. This is considered our rate determining step, which is very slow because we know that sigma bonds are really hard to break and they need a lot of more activation energy to be able to break them. So this is why we consider it a slow step. So because bromine was our leaving group, our carbon and our methyl group, they shift, making it a trigonoplanar because it doesn't have any more repulsion from our bromine. So now we go to our nucleophile, which is hydrogen. It has two lone pairs, which is partially negative, partially positive. This lone pair is the unstable lone pair and it's looking for a positive atom 2O2 to make it stable, so it goes to our carbon, which in this case is our carbocation. So then it forms, again, it feels the repulsion, so it moves to the sides, and we have our water molecule. And it's positive because now it's sharing an electrons with carbon. And we're missing hydrogens. So now that we have this, we know that this reaction happens in a beaker, so we know that there's more than one water molecule. So we add another water molecule to be able to stabilize better, which again has a lone pair, partially negative, partially positive. Again, this lone pair is looking for a positively charged atom. In this case, we have partially negative, partially positive. This electrons goes to the hydrogens, so the hydrogen. It doesn't go to the oxygen because it's already full, so it's not able to accept any more electrons. If it did, it will kick out either hydrogen or carbon, which makes it unstable, so that's why it prefers not to go there. So it goes to the next positively charged atom, which in this case was hydrogen. So it forms our carbon and our OH, and we have our OH and another H. And again, it's positively charged. So now we take our bromine that was in our beaker, move it down to here. We know that it has a lone pair, which is why it has negatively charged. It's negative charge, so it also takes, again, this unstable lone pairs. It attacks this partially positive hydrogen, again, breaking these bonds, taking the hydrogen, so it becomes HBr, our molecule originally, which was our methyl group, OH, and our water molecule. And these are our products. Did you guys understand?
I have a question. Can you try to re-explain the whole thing again? Because I got
Sure.
a little lost.
Of course. Well, class is over. I guess I'll see you next week. Okay?
Okay, so upon your request, guys, from what I understood from last class, that you didn't have a good understanding about Sn1 reactions, so today we're going to try to re-explain and simplify it for you. So, as you know, Sn1 reaction, substitution by nucleophile, union molecular. So, as of for now, as we see, both molecules here are stable. Why? Because we have no charges on them. So, first thing we do, we're going to look for the most unstable electrons, which will be the lone pairs right here on the hydrogen. And so what will happen, we will look for the most positive place for them to attack. Because for now, we don't have a positive place. So what we're going to do, we're going to add heat to the reaction. After adding heat, the electrons here are going to start moving even faster than they already do, and they will look for a more stable place for them to go, which in this case will be the bromine. Why? Because it has a bigger shell, it's more electronegative, and it will be able to stabilize those electrons better than any other atom in this molecule. Now, our bromine will be the lead group. Now, we came up with a couple of factors that maybe will help you to simplify going through an Sn1 reaction process. So, we're going to look at the substrate. Our substrate, as of for now, is tertiary. Why? Because we have 3 other methyl groups of carbons that are connected to our carbon, which will favor, if it's tertiary, it will favor an Sn1 reaction. Why? Because we have steric hindrance, and also the nucleophile, as weak, is not as strong because we don't have a negative charge. So what will happen? The lone pairs from the oxygen, after the bromine left, we're going to form a carbocation. I think what will happen is that the geometry will change. Because here, on this carbon, we don't have repulsion from this bromine no more. The geometry will change to a trigonal planar, the carbocation flat. So now our nucleophile has 2 places to attack. It could attack either from the top or from the bottom. After the nucleophile is attacking our carbocation, what happens is we have the structure over here. The oxygen becomes positive because it's now sharing electrons with the carbon. Now, as we know, this reaction happens in a beaker, which means that we don't have only one water molecule, but we have multiple. So the next water molecule with the unstable lone pair from the oxygen is going to come and grab hydrogen in this molecule, which will make it into H3O, positive, because it has another proton right now. And here we're going to have the OH, stable, neutral. Now, as you know, we have the bromine, negative here, as our nucleophile, as our lead group, sorry. The lone pairs from here are going to come and attack the hydrogen, grabbing it, and forming all our final products. So the new factors that we have for you guys are basically the substrate. You look at it if it's tertiary, secondary, primary, with knowing that tertiary is the best to favor Sn1 reaction. The second thing is the nucleophile. We need a weak nucleophile in order to favor, again, Sn1 reaction. And the third thing is the living group. You will need good or moderate or an excellent or better living group, which will form a living group without a charge. In our case, we have bromine, but it's minus the fact that we know that we have a bigger shell, we'll stabilize the electron, that will still be fine.